Hey there, it's your old pal, Mr. Cook. We're going to do the second page of the extra review for Unit 2, Part 1, so the quadratic stuff. So obviously, if we've got graphs that we need to make, that's where our graphing calculator can help out a lot. So have that handy while we're going through this stuff. So we need to find the vertex, we need to find the X-intercepts, the Y-intercepts, and also sketch the graph for two different quadratics, one in the standard form and one in vertex form. So when it's in standard form like this, it's really helpful to identify your A, B, and C values. So A is equal to 1, B is equal to -2, C is equal to -8. Because when we need to show how we get all of these values before we graph them out, we need to show our work. Because we know that you can find all this stuff on your calculator, but we want you to use your calculator to check your work and really understand the algorithms that go in here, the process that you use to solve and get specific values. Like the vertex, for example. When it's in standard form, we want to find the vertex by, let's call this part A. For the vertex, it's going to be the negative b over 2a will give us the x component of the vertex, and then we need to plug in that x value to get the y value of the vertex. Because remember, the vertex is a coordinate, so you need to find x and also y. So just using the a, b, and c values that we found, we can find the x value pretty easily. X is going to be equal to negative of b, which is -2, over 2 times a, which is 1. So please be careful with your negatives here. If there is a mistake that I see, like a little tiny stupid mistake that I have to take points off for, it's from this negative here, because it'll screw up your entire quadratic when you're trying to graph it if you forget a negative. Anyways, negative of a negative is a positive, so we have 2 in the top, 2 in the bottom, so that means that our x value is equal to 1. So for our vertex, our x value is equal to 1, and then how do we find the y value? Oh yeah, just plug it in. So if we plug in 1 for our x values here, we get 1 squared minus 2 times 1 minus 8. So 1 minus 2 is -1. -1 minus 8 is -9. So just like that, we have our vertex. When we're looking for our x-intercepts, if it's in standard form, what you want to do is either factor, if it looks like an easy expression to factor, or use the quadratic formula if it's not so easy. This one happens to be pretty easy because I can factor it pretty easily. With x-intercepts, you always want to set the y value, or the f of x value in this case, equal to 0. So if I do that, 0 is equal to x squared minus 2x minus 8. And then it looks like a problem that we needed to solve, back on this side by factoring. So we use the x method. We need to find numbers that multiply together to be -8 and add together to be -2. Those two numbers are -4 and +2. So that means that this factors to become x minus 4 and also x plus 2. So to get our x values, we just set these equal to 0. So if x minus 4 equals 0, that means that x equals 4. There's one of our x-intercepts, 4, 0. And then if x plus 2 equals 0, then if we subtract 2 from both sides, we get x equals -2. So that means that for our other x-intercept, it's -2, 0. The last thing that we need to find before graphing is the y-intercept. And in both cases, what you do is you take the x value and you set it equal to 0 and then just evaluate it. So if I plug in 0 for the x value, then I end up with 0 minus 8, which is just -8. So I've got, let's see here, 1 vertex, 2 x-intercepts, and 1 y-intercept to graph out. Looks like the biggest number that I get to is 9, so I'm going to do 9 in each direction for my graph. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So we got my negatives, and let's start graphing. So we've got 1, -9, so go over 1, down 9. There's your vertex. And through the vertex, you get the axis of symmetry, which is a vertical line, passes through the vertex, and it creates like this reflecting line where you can reflect points. Case in point is the 4, 0 and -2, 0 that will reflect over it. So 4, 0, if I go over 4, 1, 2, 3, 4, and then -2, 0, so I'd have 1, 2, wait a minute, this is off. -2, oh, because I didn't, didn't graph that right, did I? It's supposed to be at 1, -9. Okay, so that was a mistake on my behalf. Learn how to graph your coordinates, Mr. Cook. So 1, -9, so go over 1, down 9. There we go. That's where our little axis of symmetry is supposed to be. All right, so then, yeah, now this makes more sense with our x-intercepts, because one x-intercept is supposed to be at 4, 0, the other one's at -2, 0, and they should be reflected over each other. So that's like kind of a good way to, I guess, check your work, and make sure that everything makes sense in your quadratic, and it should be fine. And of course, double check it with your calculator. Our y-intercept's at 0, -8, so we can reflect that over to here, move one coordinate over to the right from the axis of symmetry, and then we've got our parabola. Remember that your parabolas are going to be either U-shaped or lowercase n-shaped. In this case, it's a U-shape, and because it's going to have a positive lead coefficient. Okay, so we can speed up the process here now that we're in vertex form, because the vertex is really easy to find. It's just the opposite of the number that's adding or subtracting in the parentheses. So in this case, it's a +3. And then the number that's adding or subtracting outside the parentheses. So in this case, it's a +8. The x-intercepts, again, we set the y value equal to 0. So we've got -2 times parentheses x minus 3 squared plus 8. And then we just simply follow order of operations. So subtract, get rid of any addition subtraction outside the parentheses. So we have -8 is equal to -2 times x minus 3 squared. Divide by any numbers that are out in front of the parentheses, or get rid of any multiplication. So we divide both sides by -2 now. And we get 4 is equal to x minus 3 squared. Then we take the square root of both sides. So square root here, square root here. Square root of 4 is 2. The square root of our squared variable is x minus 3. And remember that when we take the square root of a squared variable, we put a plus or minus in front there. And then to get x by itself, we add over the 3. So we get 3 plus or minus 2 equals x. So that gives us 2 x-intercepts. 3 plus 2, which would be 5, so 5, 0. And then 3 minus 2, which is 1, so 1, 0. So those are our 2 x-intercepts. So we got our vertex, got our x-intercepts, and then the last one is the y-intercept. And again, you just plug in 0 for x and solve for y. So if I plug in 0 for x, I get -2 times parentheses 0 minus 3 squared plus 8. 0 minus 3 is -3. And this is a delicate one because you want to make sure that you do your order of operations. So -3 squared is a +9. +9 times -2 is -18, and -18 plus 8 is -10. So that means that when we plug in 0, we get -10, and that gives us our last coordinate that we're going to need to draw out. The largest number that we get is 10, so draw out 10 hash marks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There we go. All right, so graph your coordinates out, 3, 8, and I'm going to make sure that I graph the right coordinate this time, 3, 8. So go over 3, 1, 2, 3, and then up 8, 1, 2, 3, 4, 5, 6, 7, 8. Right there. And then draw your axis of symmetry. And then we've got, let's see here, 5, 0. So 1, 2, 3, 4, 5. 1, 0. So over 1, up 0. And then also our y-intercept, 0, -10. And I can reflect that also. So let's see, it's 1, 2, 3 away from the axis. So 1, 2, 3 puts it right there. And then we've got our graph. It's just going to be like a lowercase n or a upside down U, whatever you want to call it. That's what it is. All right, so there's graphing, and of course you can always double back and check your work on those. So y equals -2 parentheses x minus 3 squared, and then plus 8, and then hit the graph button, and there's your graph right there. Yep, that looks pretty good. All right, and then you can double check this one as well if you want. These only go to 9, but it'll also look pretty close on your graph. So let's see, x squared minus 2x minus 8, and then graph. And there it is. Yeah, it's pretty close. Okay, so they look pretty good. I'd be pretty content with that. Now let's try sketch the graph here. So this is another quadratic. So when it says opens, it means does it open facing upwards or downwards? So does it, does the vertex, open up to the top or down towards the bottom. So in this case, it's just going to be moving up. Now we can find the vertex using the same method that we did before. Negative b, so negative of negative 6 over 2a, so 2 times 1. So we get positive 6 over 2, which is 3. So that's the x value on our vertex. So then we plug in 3, we get 3 squared minus 6 times 3 plus 5. So that's 9 minus 18 plus 5, so negative 9 plus 5, which would be negative 4. So 3, negative 4. Axis of symmetry, so that's a vertical line, so it's going to be the x value of the vertex. So x equals 3, easy enough. X-intercepts, so try and set it equal to 0 and then try and factor it. So numbers that multiply together to be 5, add together to be negative 6 are are negative 5 and negative 1. So then if we solve this, we get x-intercepts at 5, 0, and then also at 1, 0. All right, and then the y-intercept, if you plug in 0, 0 minus 0 plus 5 is 5, so 0, 5 is our y-intercept. Our largest number just goes up to 5, so just count out 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so that's going to be pretty easy to graph these points up now that we've had practice with those other ones. So graphing the vertex, 3, negative 4, so over 3, 1, 2, 3, and then down 4. There we go, and then our axis of symmetry is that vertical line that passes through the vertex. And then our x-intercepts are going to be located at 5, 0, and 1, 0. So they should be equally spaced away from the axis of symmetry, which they are. And then 0, 5, so go over 0, up 5. And you can even reflect that point if you want, because it's just 1 over, so let's count one more over. So there's 6, and it'll go up to 6, 5. There we go, somewhere right around there. And now you can see the parabola opening up. Looks like a little U shape. And there we go. And then you can double check it on your graphing calculator. It's going to be a little bit off with the scaling because our axis only goes up to 5 and the standard window only goes to negative 10 in each direction. But you can check that if you want. Number 14, find the number of units x that will produce the minimum cost for this. So it's actually just asking us to find the x value here, not the actual cost itself. But if it also asks us to find the minimum cost itself, then we'd have to find the c value afterwards. But we're just supposed to find the x. Now, there's a key word in here that tells you exactly what you're supposed to find, and that's the word minimum here. Minimum cost means that we are going to be looking for the vertex. So the vertex, look for words like minimum or maximum. For x-intercepts, look for like, when does it hit the ground? How much hang time does it have? How long is it in the air? That kind of thing. And then with the y-intercept, it's always going to be like the beginning value, so some initial amount or the starting amount. In this case, just minimum, so vertex. And since this is in standard form with an A, a B, and a C, you can just use the same formula we've been using for finding the vertex for number 11, number 13, and yeah, I guess that's it for just those ones. All right, so with the x value, x is equal to negative b over 2a. Our b value is negative 90, so the negative 90 over 2 times a, and a in this case is 0.01. All right, so the opposite of negative 90 is a positive 90, and then 2 times 0.01 is 0.02. And then we can just do this in our calculator at this point. So 90 divided by 0.02, and that's going to be 4,500. So 4,500 units for our answer. Just conveniently, the units on x are units, so that's what we need to do. Now, if you wanted to type this into your calculator, which you can do, just please make sure that you put the numerator and denominator in parentheses. So like you'd have to do parentheses, negative 90, and then divide that by parentheses 2 times parentheses 0.01, then enter and see you get 4,500. If you don't put the parentheses around there, you could end up with the wrong answer. Like for example, I've seen this as a common mistake. Negative of negative 90, so far so good. Divide by 2 times parentheses 0.01. This will not give you the same answer. See, the reason that it doesn't is because your calculator is kind of stupid. It only does the order of operations that you tell it to do. And that means that it's going to do division first before it does multiplication. So it's going to go negative 90. So your calculator will go, okay, that's 90. And then divide by 2. So it'll divide it by 2, so 45. And then it'll take 45 and multiply that times 0.01, which results in that 0.45. So be very careful about your parentheses when you're placing those on your calculator. All right, so for the last one, find the quadratic function that has a maximum at 1,7 and passes through the point 2,5. That's kind of clever. So they use the word maximum, but really they mean that that's just the vertex. And if you want to write out a quadratic, there are two ways that you can write it out. Either in standard form, so it looks like this, y equals ax squared plus bx plus c. You would need probably a coordinate and, no, probably 3 coordinates to solve this one, because that'd be 3 unknown values. Yeah, so, you know, don't use this one too often. The one that you're going to use more often is the vertex form. So y equals a times parentheses x minus h squared plus k. All right, so that's the template that we're going to use to write this out. That's what it's going to be for the majority of these problems. And the numbers that you need to find are the following. You need to find the a value, you need to find the h value, you need to find the k value. And I got great news for you. If you have the vertex, you have the h and also the k. They're given right up front for you, okay? So I can just write those values in as they are. Y equals, I don't know what a is, but I have x minus my h value, which is 1 squared, and then plus my k value, which is 7. I just need to find that a value, and I'm all done. So to find the a value, what you do is you plug in all the stuff that you already have, but you also plug in this other coordinate. That's why this other coordinate is necessary. You need an x and a y value that will work in this equation. So we plug in the y, the x, the h, and the k, because then the only unknown value that you have is that a value. So let's do that. So we're going to plug in 5 for y, so 5 equals a, we don't know what a is, and then x, which is 2, minus h, which is 1, squared, plus k, which is 7. So we get 5 is equal to a times parentheses, 2 minus 1 is 1, so 1 squared, plus 7. Remember to follow your order of operations, so you need to multiply these together before you add that 7. So 1 squared is 1, and 1 times a is a. So a plus 7 equals 5. And then if we subtract 7 from both sides, we get our answer for a. A is equal to negative 2. So that gives us the last value that we need for our quadratic expression. And we are all done. So that concludes the extra review, page 2. If you have any additional questions, don't be afraid to email your teacher or ask for help in some other way. Maybe sign up for ACLAB or whatever. But that's it. So I hope you have a great day. Thank you very much for watching.